Okay, welcome. Dr. Hamed Hameda, Assistant Professor of Physiology. We will start on the respiratory system physiology. The first step in studying the respiratory physiology is to mention the functions of the respiratory system. For any student, it is easy for him to memorize that the respiratory system has three main functions. The first function of the respiratory system is provision of oxygen. Provision of oxygen means taking the oxygen from the atmosphere and entering it inside the blood. This oxygen is necessary for the metabolism of the body. The second step is elimination of carbon dioxide. You know well, carbon dioxide results from metabolism in the tissue, and this carbon dioxide should be eliminated from the body or from the blood, not because carbon dioxide is a toxic gas, but because any change in carbon dioxide will change the pH. The third function of the carbon dioxide of the respiratory system is the acid-base balance or pH regulation. As we regulate the carbon dioxide level in blood, this ultimately will regulate the acid-base balance or the pH. pH regulation is very necessary because many enzymes and proteins in the body act within a very narrow limit of pH. So again, the most important three functions of the respiratory system are provision of oxygen, elimination of carbon dioxide, and regulation of pH. These are the main three functions of the respiratory system. Also, the respiratory system has a defense mechanism. It protects us against invading organisms as well as foreign bodies. These mechanisms are different in the respiratory system. For example, cough is one of the mechanisms by which we can eliminate foreign bodies and dust that entering our respiratory system. Sneezing is also mucous membranes. The mucous membrane lining the respiratory system protect us by sticking of the foreign bodies and particles to the respiratory system. The IgA or immunoglobulin A, which is called the secretory immunoglobulin. You know well there are many types of immunoglobulins. The immunoglobulin A or antibody A it's called the secretory immunoglobulin, which is found mainly in the mucous membranes of the respiratory system, the gastrointestinal tract, and the urogenital tract. Also, the epithelium of the respiratory system is a ciliated epithelium. And this cilia is very important in moving up foreign bodies and particles to be coughed out. Also, one of the mechanisms is the alveolar macrophage. You know well, macrophages are originally a monocyte that enter the tissue and change in size to make or to form the macrophage. Macrophages are different tissues are called according to the tissue. For example, in the liver, we call it the Kupffer cell. In the lungs, we call it the alveolar macrophage. This alveolar macrophage can engulf any dust or particles or foreign bodies that escape the protective mechanisms in the upper respiratory tract. Also, one of the protective mechanisms is the hair in the nostrils. Our nose are filled inside with the hair. This hair stops or filters the air before entering into our respiratory tract. Also, the mucus that's secreted by our nose is also a protective by eliminating the foreign bodies and particles. Let us summarize the functions of the respiratory system. The first function of the respiratory system is provision of oxygen, توفير الأكسجين for the metabolism اللي هو للبودي عشان بيحتاج الاكسجين، التخلص من ثاني اكسيد الكربون لانه ثاني اكسيد الكربون بيعمل تغيير في البي اتش، وبالتالي ويريجوليت ذا اسيد بيز بالانس. واحده من الميكانيزم برضه اللي هو او الفانكشنز والديفنس ده بيتم عبر different mechanisms. Also, the respiratory system function is modification of air. Usually, we inspire a dry air from the environment. This dry air may damage our respiratory tract, so we need to add a water vapor. لازم نعمل له إضافة بتاع بخار ماء وده بيسميه modification of air. Modification means adding water vapor أو بخار الماء. Also, cooling or warming of air. If the temperature of the inspired air is less than our body temperature, then we will warm the air. And if the temperature of the air is more than our body temperature, we will make cooling of the air. So the temperature of the air should be near to our body temperature. Voice production, the vocal cord and the larynx plays a very important role in regulation or in production of voice. So as the larynx and vocal cord are part from the upper respiratory tract, they help or participate in voice production. The last function of the or one of the important functions of the respiratory system is smell, and the nose, the receptor for smell, are found in the nasal cavity, and the nasal cavity belongs to the respiratory system. So again, the main functions of the respiratory system are provision of oxygen to the blood from the environment to enter inside the lung, and then from the lung to the blood, and elimination for carbon dioxide from the blood to the lungs and then to the atmosphere, and regulation of pH through regulation of carbon dioxide. Defense function through different mechanisms. Also, humidification of air by adding a water vapor, cooling or warming of air to make it near to the body temperature, voice production through the larynx and vocal cord, and smell through the receptors of olfaction that are found in the nasal cavity. The other function of the respiratory system is metabolic function. The respiratory system synthesizes certain substances, activates certain substances, and inactivates certain substances. The substances that are synthesized by the respiratory system are the prostaglandin E2 and the surfactant, which will be discussed in the coming lectures, and it activate the angiotensin 2. You know well, renin is produced by the kidneys, and renin converts the angiotensin gene to angiotensin 1. Then the angiotensin 1 is activated to angiotensin 2 through the angiotensin converting enzyme. This angiotensin converting enzyme is found in the pulmonary capillaries. So one of the main functions of the lung is to convert angiotensin 1 to angiotensin 2. Also, the lungs inactivate the bradykinin and serotonin. Remember well, the enzyme that activate angiotensin 2, the angiotensin converting enzyme, is the same enzyme that inactivate bradykinin. So patients who are taking angiotensin converting enzyme inhibitor sometimes develop accumulation of bradykinin in the respiratory system, leading to persistent dry cough. In this case, remember, this accumulation of bradykinin is due to inhibition of the enzyme, angiotensin converting enzyme, that causes inactivation of bradykinin. In this case, we stop the drug and we change the patient to another type of drugs or other groups of drugs. So back again, the main functions of the respiratory system are provision of oxygen, elimination of carbon dioxide, acid-base balance, defense mechanism, humidification of air, cooling or warming of air, voice production, smell, and metabolic function. So these are the main functions of the respiratory system. After discussing the main function of the respiratory system, we will go to the functional anatomy of the respiratory system, because to understand the physiology of the respiratory system, we need to have some anatomical review about the respiratory system. Well, the respiratory system extends from the nose or from the nasal cavity up to the alveoli inside the lungs. So it includes the nasal cavity first, the pharynx, the opening of the different or the hole, which is contain many openings, and then from the pharynx we go into the larynx. The larynx is guarded by the glottis and the vocal cord, then the trachea, then the bronchi, and the single of them is called the bronchus. After the bronchi is divided into many bronchioles, and after the bronchioles we will have the alveolar duct and the alveoli. You can see here in this diagram the component of the respiratory system. Here we start from the nasal cavity up. We can be back to the respiratory for the first diagram in the title page to see the different parts of the respiratory system. Here, this is the nasal cavity, this is the pharynx, this is the larynx, this is the trachea, two main bronchi. Then we can go down in another diagram to see the different parts. You can see here, this is the main bronchus, this is the two bronchi, then it is divided into bronchioles, then after the bronchioles, the alveolar duct, the alveolar sac, and the alveoli. We can divide the respiratory system into upper airways and lower airways. This is anatomical classification, but not physiological classification. We classify the respiratory system anatomically into upper airways and lower airways. Remember, the respiratory system extends from the nasal cavity to the alveoli, and it includes the nasal cavity, the pharynx, the larynx, the trachea, the bronchi, the bronchioles, the alveolar ducts, and the alveoli. From the nasal cavity to the pharynx to the larynx, including the glottis and vocal cord, we call this the upper airways. We call this the upper airway. So the upper airway includes nasal cavity, pharynx, and larynx. While the lower airways include the trachea, the main bronchi, the bronchioles, which include two types of bronchioles, the terminal bronchioles and the respiratory bronchioles, the alveolar ducts, and the alveoli. You can see in this diagram, as I mentioned, this is the lower airways from the main bronchi, trachea, main bronchi, bronchioles with the terminal bronchioles and respiratory bronchioles, and the alveoli. We can further subdivide the lower airways into conducting zone and respiratory zone. The conducting zone, this is a part of the lower airway where there is no gas exchange. And this the function of this area is only to conduct the air from outside to the exchange zone or to the respiratory zone. Now let us see what are the parts of the conducting zone and what are the parts of the respiratory zone. This classification is based on the presence or absence of alveoli. If the part contains an alveoli, we call it respiratory zone. If there is no alveoli, we call it conducting zone. Now to understand it more, remember we divide the respiratory system into upper airways and lower airways. The lower airways are further subdivided into conducting zone and respiratory zone. So the whole respiratory system is divided into upper airways and lower airways. The lower airways are divided into conducting zone and respiratory zone. This classification is based on presence or absence of alveoli. If we have an alveoli in this part, it will belong to the respiratory zone. And if there is no alveoli, we will say this is a part of the conducting zone. يعني لو في وجود alveoli في هذا الجزء بنسميه respiratory zone. إذا ما في alveoli بنسميه conducting zone. لكن generally بنقسم respiratory system ل upper airway و lower airway. lower airway بنقسمه ل conducting zone و respiratory zone. طيب نجي نشوف what is the lower airways part. The lower airways part is the conducting zone and respiratory zone. The alveoli, what is an alveoli? Alveoli are dilated end of the respiratory. You can see here the fantastic structure of the alveoli. They are thin walled sac. This alveoli function is exchange of blood. That is why they have a thin wall. يعني the main function of the alveoli is gas exchange. Alveolus like this, and it is near to it are the capillaries. Here where the oxygen is taken from the alveoli to the blood and carbon dioxide from the blood to the alveoli. So alveoli are the sites for gas exchange. So alveoli are small size, thin wall, and they are surrounded by many capillaries. You can see in this diagram, here this is an artery, or this is an artery coming, which is the pulmonary artery carrying a venous blood with less oxygen. Then gas exchange takes place here, and then after it takes place, there is an exchange at the level of the alveoli and return back at the pulmonary veins as an arterial blood with high oxygen content. So this is the alveoli. Now let us back to the conducting zone. Remember, we divide the respiratory system into upper airways and lower airways. The upper airways, the lower airways are divided into conducting zone and respiratory zone. Remember, the lower airway extends from the trachea, the bronchi, the terminal bronchiole, the respiratory bronchiole, the alveoli, and the alveolar sac and the alveolar ducts. So which part are belong to the conducting system and zone, and which part are belong to the respiratory zone? The conducting zone contain the trachea, the bronchi, and the bronchioles up to the terminal bronchiole. This is the end of the conducting zone. So from the trachea till the terminal bronchioles is called the conducting zone. And from the respiratory bronchioles, which is the area that contain the alveoli, we have the respiratory zone, which contains the respiratory bronchiole, the alveolar duct, the alveolar sac, and the alveoli. Again, let us be back to see the two parts. This is the conducting zone here. This is the conducting zone. When I said the conducting zone, the trachea, the two bronchi, up to the terminal bronchioles. And then from the respiratory bronchioles, here you see the respiratory bronchioles, the alveoli, the alveolar duct, and the alveolar sac. This area from the respiratory bronchiole downward contain alveoli, and there is gas exchange. So the respiratory bronchiole, the alveolar duct, the alveolar sac, and the alveoli. So now we can simply divide the respiratory system as a whole into two main parts, into an area with alveoli and area without alveoli. We can just draw the respiratory system by this diagram. This is called the conducting zone. And conducting zone, there is no alveoli. And of course, there is no gas exchange. And the second part this is called the respiratory zone, or we call it the exchange zone. And this contains alveoli, and there is a gas exchange. So we have two zones, the conducting part or conducting zone, where there is no alveoli and no gas exchange, and a down area of the respiratory zone, which is there is an alveoli and there is gas exchange. Remember, here the function of this part is to enter the air in and out of the respiratory zone. So the function of the upper zone is to enter or to conduct the air to the respiratory zone. That is why we call it the conducting zone. And the respiratory zone or exchange zone, this is the area where gas exchange occurs with capillaries. So you can see again, I can draw the diagram like this and like this. Here are the capillaries. This area contains alveoli and there is gas exchange, oxygen and carbon dioxide. Why this is the conducting zone to enter the air and to exhale the air outside. So now we can divide the respiratory system as a whole to conducting zone and exchange zone or respiratory zone. From anatomical part of view, we can divide the respiratory system again into a conducting zone and exchange zone or respiratory zone. The other name for the conducting zone is the dead space. Dead space, what is dead space? Anatomically, the dead space is the area that does not contain alveoli. Any area in the respiratory system that does not contain alveoli is called the conducting zone. It includes the conducting zone of the lower respiratory tract, as well as all the upper airways. Remember, we divide the respiratory system into upper airways, lower airways. The lower airways are divided into conducting and respiratory zone. So, whole upper airway plus the conducting zone are called anatomical dead space because both of them do not contain any alveoli. The upper airways and the conducting zone of the lower airways. While the respiratory zone of the lower airway contain alveoli and there is gas exchange. So as a whole, we can divide the whole respiratory system into a dead space, no alveoli and no gas exchange, or an exchange zone or respiratory zone where there is alveoli and there is gas exchange. So now the concept of dead space. What is the dead space? The dead space contain anatomically the upper airways and the conducting zone of the lower airways. And we can say simply it extends from the nose till the terminal bronchioles. Now from the nose till the terminal bronchioles there is no alveoli. So we call it the anatomical dead space because it does not participate in gas exchange with blood. You can see it again in the diagram I drew before here. This is the anatomical dead space. There is no alveoli and no gas exchange. It extends from the nose till the terminal bronchioles. Then from the respiratory bronchioles downward, this is the area of alveoli and there is gas exchange. What is the function of the anatomical dead space? Is to conduct air to the respiratory zone. Conducting air means helping in entering and exit of air. That means it's just enter the air to the lung and take out the air from the exchange zone. At the upper airway is the conducting zone. If you breathe, for example, 500 per breath, the anatomical dead space takes about 150 ml from each breath. This 150 is constant. That means if you breathe 300, the dead space will take 150. If you breathe 500, the dead space will take 150. So it is a fixed amount. Now, in physiological concept, this is anatomical. This classification is anatomical, and it is based on presence or absence of alveoli. يعني التقسيم بتاع الاناتوميكال بيعتمد على حاجه واحده، هل في alveoli ولا ما في alveoli؟ إذا ما في alveoli بنسميها anatomical dead space. إذا في alveoli بنسميها respiratory zone أو exchange zone. لكن في الفيزيولوجي it is a functional division. The question is not is there any alveoli or no. The question is that is this in this area is there any gas exchange or not. يعني هل المنطقة دي فيها جاز اكسجين ولا ما فيها جاز اكسجين؟ طيب قد يكون طبعا أي منطقة ما فيها الفيولاي ما فيها جاز اكسجين. خلاص إذا كل الاناتوميكال ديد سبيس هو عبارة عن فيزيولوجيكال ديد سبيس. طيب هل في منطقة ممكن يكون فيها الفيولاي لكن ما شغالة جاز اكسجين؟ دي في الاناتومي بتعتبر ريسبيراتوري زون مع إنها ما شغالة لكن فيها الفيولاي. لكن في الفيزيولوجي بتعتبر شنو؟ بتعتبر فيزيولوجيكال ديد سبيس. أي نون فانكشنينج الفيولاي بتسمى ديد سبيس، وأي منطقة ما فيها الفيولاي بنسميها فيزيولوجيكال ديد سبيس. إذا what is physiological dead space? It is a part of the respiratory system where there is no gas exchange. ولكن ديبيت كان في الاناتوميكال ديد سبيس إنه the area of anatomical dead space the area there is no شنو alveoli. سواء كانت الالفيولاي هي functioning or not functioning. ولكن الفيزيولوجيكال ديد سبيس هو المنطقة اللي ما فيها جاز اكسشينج سواء فيها الفيولاي أو ما فيها الفيولاي. لكن في النورمال سبجكت عادة لأنه كل الالفيولاي are functioning الاناتوميكال ديد سبيس equal to the physiological dead space. ولكن في الابنورمال سبجكت نحن بنضيف معانا أي function unfunctioning alveoli. So الفيزيولوجيكال ديد سبيس بيساوي الاناتوميكال ديد سبيس بلس ذا نون فانكشنينج الفيولاي. اذا النون فانكشنينج الفيولاي بتدخل مع الفيزيولوجيكال ديد سبيس لكن ما بتدخل مع الاناتوميكال ديد سبيس لانه الكلاسيفيكيشن بتاع الاناتوميكال depends on absence or presence of alveoli. ما بيعتمد على انه الالفيولاي شغاله ولا ما شغاله. It is a structural rather than functional classification. So these are the two important concepts, the anatomical and physiological dead space. Now I will have a quick review on the histology. The airways are lined by ciliated columnar epithelium. والكلام ده من up to the level of the respiratory bronchiole. What is the importance of this cilia? The cilia is very important because the movement of this cilia with the mucus propels the foreign particle trapped up to the pharynx. It can be coughed or sneezed and can be swallowed or expelled outside. معناها السيليا مهمة جدا as a protective mechanism in the respiratory system. Then let us remember that as we are going up in the airways from up downward, there are certain chains. What are the two chains? انت ماشي من النوز لحد الالفيولاي. اللي بيحصل شنو؟ في التراكية بيكون you have C-shape or nearly a circle of cartilage. As you are going down, and there is few smooth muscle. As you are going down, two chains occur. The amount of cartilage decreases and the amount of smooth muscle increase. And then half by half. Then small and more smooth muscle. Till you reach the bronchioles where there is a pure smooth muscle. Remember again, from the nose going down to the alveoli, the chains are, there is decrease in the amount of cartilage and increase in the amount of smooth muscle. Why? Because in the trachea, the cartilage is very necessary to keep the trachea open throughout the time. But in the bronchioles, there is smooth muscle where we can control them. We can increase the size or we can decrease the size. In the alveoli, there is another structure or another histology. So I will mention that the cartilage is important to support the large airways, the trachea and main bronchi, and there is no cartilage in the bronchioles. As we go down, there is smooth muscle, and the airway contains smooth muscle in order to control them by dilatation or constriction to a certain stimuli. إذا أنت كل ما تنزل لتحت كمية الكارتلج بتقل وكمية السموث ماسل بتزيد، وبالتالي دي بتدينا فرصة. الكارتلج مهم جدا عشان يخلي التراكية مفتوحة لدخول وخروج الهواء. أما السموث ماسل هنا بتساعدنا في البرونكيول في إننا نغير في الديامتر أو في القطر بتاع البرونكيول. دينا الشكل اللي هي دينا المين لاير اوف كارتلج اند سموث ماسل. لما نصل الالفيولاي اللايننج مختلف شويه. كيف يعني؟ الالفيولاي have a specific type of cell. We have two types of cell in the alveoli. عندنا type 1 alveolar epithelium or type 1 alveolar cell و type 2 alveolar cell. type 1 alveolar cell هي الأغلبية وهي تمثل حوالي 95 أو 90% من 95 إلى 95 وهي فلات سيل وظيفتها الغاز اكسجين. عندنا تايب 2 وهي تمثل من 5 ل 10% تقريبا ودي وظيفتها برودكشن اوف سيرفاكتنت يعني ما بتشارك في الغاز اكسجين. إذا نحن human being contain about 300 million alveoli وزي 2 types of cell in the alveoli. زي ما قلت تايب 1 وهي البرايمري سيل وهي المسؤولة عن الغاز اكسجين وهي تمثل حوالي 95% من مساحة الالفيولاي. This is type 1 alveolar epithelium which is responsible about gas oxygen. عندنا type 2 epithelium وهو بيفرز لنا surfactant and as I mentioned we have another session which will talk about the surfactant. أيضا one of the other function of the type 2 is to regenerate type 1 cell. يعني إذا حصل death في type 1 it will be replaced by type 2. إذا we have type 1 which is a simple flat square cell for gas oxygen and we have type 2 which is surfactant producing cell. Remember 95% من الخلايا are type 1 and 5% are type 2. So these are the main cells of the alveoli. To sum up, the respiratory system extends from the nose till the alveoli. From the nose till the terminal bronchiole, there is no alveoli and no gas exchange. We call it the anatomical dead space. From the respiratory bronchiole to the alveoli, alveolar duct and alveolar sac, they contain alveoli and there is gas exchange and we call it the exchange zone or the respiratory zone. Histologically, as we are going from the trachea down, the amount of cartilage is reduced and the amount of smooth muscle is increased. In the alveoli, there are two main cells, type 1 alveolar cell, which is responsible about gas oxygen, and type 2, which is responsible about production of surfactant. So these are the main histology of the respiratory system. Now remember, I would like to talk finally about the innervation of the respiratory system. Well, the respiratory system is innervated by the autonomic nervous system, the both divisions, the sympathetic and the parasympathetic. Remember, the sympathetic comes mainly from the thoracic segment of the spinal cord. And you remember that the sympathetic originate from the thoracolumbar outflow. That means they originate from the thoracic segment of the spinal cord as well as the lumbar part. This goes down and have a postganglionic neuron, and here the neurotransmitter is noradrenaline. And the main receptor are the beta-2 receptor. So the main receptor in the respiratory system for sympathetic is the beta-2. Again, it is the thoracic segment. It is the neurotransmitter is noradrenaline, and the receptor are beta-2 adrenergic receptor. So sympathetic nervous system, don't forget, the lungs are innervated by both divisions of the autonomic nervous system. And we have a sympathetic and parasympathetic. The parasympathetic from the vagus nerve, and the neurotransmitter is acetylcholine, and the receptors are muscarinic receptor. So now, the parasympathetic originates from the 10th cranial nerve, which is the vagus nerve. The acetylcholine. Acetylcholine causes airway constriction. That means it causes bronchoconstriction and increased glandular secretion. And this will lead to narrowing and increased secretion in the respiratory tract. And sympathetic nervous system through thoracic, and the neurotransmitter is norepinephrine, and the receptor are beta-2 receptor. So beta-2 receptor causes bronchodilation. So sympathetic causes bronchodilation through beta-2, and parasympathetic causes bronchoconstriction through muscarinic receptor. In asthmatic patient where there is a bronchoconstriction, we need to cause bronchodilation. We can cause bronchodilation by two ways. Either by stimulating the sympathetic, giving the patient beta-2 receptor agonist, a drug that stimulates the beta-2 receptor. This drug which stimulates the beta-2 receptor will cause bronchodilation. An example of that is salbutamol with the trade name Ventolin, which is used as aerosol or used as spray to dilate the bronchioles. And also we can inhibit the muscarinic receptor of parasympathetic. Remember, sympathetic causes bronchodilation and decreased glandular secretion or glandular mucus secretion. So to sum up, we have two innervation for the respiratory system receives dual innervation الاثنين من السيمباثيك ومن الباراسيمباثيك. السيمباثيك بيجي من الثوراسيك والنيوروترانسميتر is noradrenaline والريسبتور بيتا 2. والإفكت بتاع السيمباثيك على الريسبيراتوري سيستم بيعمل برونكودايليتيشن وبنقص الميوكاس سكريشن. الباراسيمباثيك بيطلع من الفيجاس نيرف والنيوروترانسميتر اسيتايلكولين والإفكت هو برونكوكونستريكشن وانكريز ميوكاس secretion. So these are the innervation of the respiratory system. So to sum up this this lecture was about a quick review on the anatomy, the innervation, and the functions of the respiratory system. By this we end our lecture today, and we'll continue in the next lecture inshallah about the lung volumes and capacities.